All right, ladies and gentlemen, probability stats, grace quiz preview can do nothing but help, so let's jump right in here. Researchers give one group a new cold medicine and compare them to a group that's given a placebo. What is the group that's given the placebo? Now, we got two things we got to consider here. First, is it an experiment, a survey, or an observational study? There's my keyword. The researchers give them. They're not just watching, they're actually involved here. So it's an experiment. So we know it's neither of those. Then, what's the group given the placebo? Not the medicine, but something fake. Okay, treated group would be the medicine, leaving the control group. All right, so got that one. Again, take your time. Two letters are selected at random from the word space. What's the probability of selecting two vowels? Two vowels means there's two events. Two probabilities to calculate. First time, success, which would be a vowel. 1, 2 of those out of 5 total letters. But then once I take one out, let's say I grab the A out of a hat and I'm holding it now, how many vowels are left? 1 out of how many letters total? 4. Okay, that's why we got to do them separately. We can't just do it as one and call it 2 out of 5. Multiply those across. 2 over 20 reduces to 1 out of 10. Okay. A die is rolled. What are the odds? Remember, success over failure, win over loss, of rolling a 6 or a number greater than 4. So as we look at this, we've got to say, okay, let's maybe start with the probability. And I say that because I've got two kind of events going on here. So let's think about this for a second. Let's say it was probability. Okay, what's the probability of rolling a 6? 1 out of 6. Or, and we've talked before, that's plus, or rolling a number greater than 4, which would be 5 or 6. However, notice the 6 shows up in both lists. So I need to take that back out. So that would be my probability. You're like, okay, why did you just do all that? Because now, remember, probability is success over total. Odds is success over fail. So success is still 1, and if there's 3 total, it means I failed twice. You're like, okay. Not bad. Okay, Heidi, Tom, Carol, and Bill are up for promotion. Bob's going to choose a team of 2 to lead the group. Everyone's likely to get the position, show the possible teams. We've talked about this before. Just pick one of them. I usually just work left to right. Okay, Heidi could go with Tom, Carol, or Bill. Then Tom could go with Carol or Bill, because remember, I couldn't do Tom, Heidi, because that's the same team. And I just keep working my way out until I run out of people. So I see there's 6 possible teams. 1, 2, 3, 4, 5, 6. Team of 2. You're like, hey, I've seen something like this before. Oh, yeah. Heidi and Bill are the team. 1 way out of 6. 2 men. Oh, this is where I should have put names. Okay, Tom and Bill. Tom and Bill. And that's all I can do, basically. But it's good visually to be able to see that and then to be able to count them out. But I might actually write the names out next time. Okay, what are the odds of drawing a red marble from a bag that contains 3 red, 2 blue, and 1 yellow marble? Okay. So here, it would be red over not red, because again, it's odds. Red marble, there's 3. Not red, there's 3. And we want to reduce it. And again, I don't care if you don't go to the colon. We normally do, though. We normally do probability as a fraction and odds with the colon. But the bigger thing here is that you get the right numbers. All right. In a class, there are 7 juniors and 12 seniors. There's 5 junior females and 7 senior females. Now, we've talked about this before. When we start getting into this, we're like, okay, well, what does that mean for the males then? If there's 5 junior females, 7 juniors, that'd be 2 male juniors. 12 seniors, 7 senior females, would be 5 senior males. That just may come in handy. We don't know. Probability of a senior or female. Or means we're adding. So seniors, there's 12 total out of how many total? 19. Or female, 5 and 7 is also 12 out of 19. But be careful, because what? Probability can't be greater than 1. So 24 over 19 to be great. What do I have to get rid of? Oh yeah, I got to minus the overlap. Senior females need to be taken out. So 24 minus 7 is 17 over 19. And that's how that one would come up. Okay. Junior or male. Same idea. Juniors, 7. Males, let's see here, that's also 7. And even though it's less than 1, don't think you're just done. Then junior males, 7 and 7 is 14 minus 2 is 12 over 19. And then a junior or a senior. Okay, so juniors, I got 7 out of 19. Seniors, I got 12 out of 19. And you're like, wait, you didn't subtract something. Well, I don't think you can be a junior and a senior at the same time, so we don't have any overlap. So that one gets us good to go on that one. Okay, so you notice a lot of this stuff, it's nothing that's too bad. It's just kind of playing a little bit. All right. Probability of being overweight. Overweight, there's 66. There's 112 total. Always want to reduce our fractions down as much as we can. Okay, so probability, not a whole lot to think about. But then be careful. Probability of normal weight given female. Remember, that means whatever is second, whatever my B is, goes on in the denominator. A and B together is my numerator. Normal weighted female over total females. Gotta remember that little step in there. You can kind of get messed up. And then finally, overweight or male. We just got done doing some of these. So overweight, 66 out of 112. Males, 62 out of 112. And here you'd get the obvious. If you did try to put them together, it'd be greater than 1. You'd be like, I can't do that. Not with probability. Odds, yes. Here, no. And then minus my overweight males. Which gives me 83 over 112, which doesn't reduce. In a class of 35 students, how many different committees of 4 students can be chosen? Now let's think about this. Now, could I do it this way? Maybe, but there's a simpler way. Is this a permutation or a combination? Does order matter or not? So here, order doesn't really matter. It's just committees. It's not like I'm choosing a president, vice president, secretary, treasurer, something like that. So this would be a combination. So I'd have a combination of 35. I'm going to pick 4. And we talked about how we can do this on the calculator pretty easily. Let me get some of that brightness down here. So we clear that out. We type in our 35. And then it's math. You push this up a little further here. We got to pay attention. It's combination. And we're going to pick 4. 52,360. Now, some of you may be asking, well, when we were doing it before, sometimes we'd do it with the blanks like this. I remember you doing it where we'd go like this. So why can't I do it that way? Well, there's a couple of reasons. First, the number ends up being a lot larger. And the reason for that is that would be a permutation. That would have been if we have a president, vice president, secretary, things like that. So we do not We don't want permutation. We want combination. Okay, so I just got to do that. Use your calculator. Keep it simple. All right, a little more odds. The odds of a player making a free throw are 3-2. Success. Fail. If he shoots 25 free throws, how many do you expect him to make? Okay. So if this is success to fail, if he shoots 25, how many would you expect him to make? Let's think about that for a minute. So if this is the case, he succeeds 3 out of every 5, right? 3 successes, 5 total. If he shoots 25, how many is he going to make? Do my little cross multiply here. And get my answer. Okay, so I'm taking my knowledge of odds, turning it into probability so I can make an equalized proportion to get that value. Which measure of central tendency? So when we see outliers involved in a data set, that already is going to screw up a couple of these. Okay, outliers mode. If your mode is an outlier, that's bad. Variance isn't even one of our modes. Okay, here. Mean and median. Now again, median we're putting the numbers in order. Mean we're just taking them all. So if we're looking towards the middle, the median would be our best thing if we have an outlier to be dealing with there. So then data sets, speaking of mean and median, okay, find the mean, find the average. So a couple ways you can do this. I'd say the easiest way is just go ahead, add up all the values, and divide by what you have. Now, if you want to go this route, that's pretty straightforward. But let's say you wanted to go to the stat, because we're going to do that for standard deviation here in a minute. Remember, if we're going to do that, we go to stat. We're going to edit our list. If there's a list there already, the quickest way to fix that is to go to the top and hit clear, and then come back down so I don't have to delete every single one of them. And then we just type them in one at a time, hitting enter after each one. Once we get that, again, we go back to stat. Go over to calc. We just want the first one on the top, variance stats, and hit enter and tell it to calculate. And it's going to rock out all the numbers that we need. Now again, if we would have done it this way right away, there's our mean up at the top, our x with a line over it. Now, our standard deviation, I have to be careful because remember, there's 2 different ones. Both of these are standard deviation, but there's a difference in the 2 in that S of x is for a sample. Oh, it says sample. Okay. So if that's the case, in this case, we're going to want the 4.7. Because if you use the other one, which is a legit answer, there's letter C, but that's not the one because that's for an entire population. But we are told this is a sample. So read carefully when you're doing this. See, is it a population? Is it a sample? All right, so as we flip over, 15 again, which measure of central tendency is not a good representation of the data? Well, here, let's see. I notice as I'm looking through these, the only temperature that seems to repeat is 66. Now, does that seem an accurate depiction of the temperatures? Not really, because the 66 is like almost the high for the entire, well, low temperatures. Oh, wouldn't it be great if that were your low temperatures? Holy moly. So mode, because mean would get me pretty close. Median, there's not really an outlier that's in there, so that would be an okay representation too. So definitely mode, because it's not. Okay, standard deviation. Okay, this one's going to take a minute. So stat, edit, clear those out. $61, $57, $54. Uh-oh. Now see, those things can get you in trouble. I hit plus instead of hitting enter. Always a good thing to double check here. So let's make sure I got these all in. 52, 53, 55, 56, 60, 65, 66, 67, 66, 61. Oh, see, I almost forgot 57 in there. That's the other good thing. Notice, again, we've talked about this before. There's 12 months. I should have a little 12 in there. I noticed I had an 11, so that was one of the reasons I knew I had to go back and look at something here. So standard deviation, we want to do stat, number 1. Calculate that sucker. And so again, now I have to make a choice. Now, luckily for me on this one, because I noticed there's 2, there's like 5.6 and 5.3, but if I look at the answers, there's nothing besides the 5.3, so that kind of helps me out a little bit. All right, pottery. Diameters of pottery bowls are normally distributed. The mean of the diameters is 22 centimeters, standard deviation is 2. What percent of the bowls have a diameter between 18 and 26? Okay, remember, when we're looking at these, the mean is 22. As I go off a standard deviation to each side, I catch 34% of my information. When I go another standard deviation, I catch another 13.5. When I go another standard deviation, break this apart a little more, I get another 2. Finally, when I get way out 3 standard deviations, I get another half. So plus or minus 1, plus or minus 2, plus or minus 3, and so on. So, what percent of bowls are between 18 and 26? Drawing the picture might help me a little. So if I add those all up, my 68 and my 27, that would give me about 95%. That's probably the best way to go about it. Let's just kind of take a peek at that and see how that's going to work. All right, find the mean, median, and mode. Again, don't make this difficult. We're going to edit our list again. Type these in carefully. Make sure I'm not doing anything silly like hitting add like I did before. Or typing in something just flat wrong. Okay. Did I have 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. Okay, and I'll let the calculator do the work for me. All right, so my mean is 165. So I would eliminate that guy. My median, I just got to go down a little further, is also 165. Eliminates that guy. And then my mode. Now again, mode, which number shows up most often? Well, 175 does. So it's going to be letter B. And as we continue to go on, about what percent of students score between 60 and 65? Again, I'd at least make myself a quick sketch like this and go, okay, so 60, 55, 65, 50, 70, 45, 75. What percent of students score between 60 and 65? Just this piece. Just this piece, about 34. What percent of students scored less than 45? So 34, 13.5, 2, there's the 0.5 part. So 20 is going to be A. And finally, in a survey, 320 students, 32% spent at least 1 hour per night on homework. Find the margin of sampling error. Remember, the margin of sampling error is taking the square root of how many people you surveyed. So, 1 divided by the square root of 320, okay, is about 5.6%, and that's all I have to do. It's not asking me any other information like it has in some of our other questions. Just the sampling error, just knowing it's 1 over square root of 320. You're good. Okay? So that covers it. Hopefully you've been able to watch this and kind of get an idea of how this is going to work, feel a little bit more comfortable. And hopefully this grace quiz goes well for you if you need it. We'll see you later.